All right, 7a from page 434. We're going to go ahead and plug in 3i. So you do 2 times 3i cubed minus 3i squared plus 18 times 3i, that's an I, minus 9. If you go to your calculator and make sure that it's in complex mode, remember you go to mode and then you go down to a plus bi, it should produce 0 when you plug that in. Once you confirm that, you know that one of the solutions, one of the roots to this problem will be 3i. So if you want to go ahead and confirm that, that should produce 0 in your calculator. You're not graphing it, you're just going to a regular screen and you're plugging in 3i everywhere you see an x. Once that's confirmed, we can take this y equals equation and convert it into factored form. So here starts 3b, if you 7b. If you had a question on 7b, here we go. Once you confirm that 3i is a 0, you go to your equation and you plug in x minus 3i. And one of the things that we've talked about throughout this chapter is that if there are imaginary roots, or if there are complex roots, there are always complex conjugates of each other. So if 3i is one of the solutions, so is negative 3i. So if x minus 3i is one of the factors, x plus 3i will be the other factor. What we still don't know is root number 3. So that's going to be what we have to find. So what I'd like you to do first is I'd like you to FOIL the complex part above the brackets. So go ahead and do first times first and last times last. Why didn't I mention the OI? The OI? Because they cancel. You'll have 3ix and minus 3ix. If you do outside, inside, they're going to cancel because you have conjugates of each other. So let's go ahead in green. Green means we're good to go on this part. If you do first times first, you get x squared. If you do last times last right here, you get negative 9i squared. What's that turn into? Plus 9, right? Plus 9. So we know that x squared plus 9 is one of the factors of this polynomial. Now that we know that, we're going to use long division to find the other factor. So here's a practice in long division. We now know that, do you remember our Q, D, and P, I think it was? We said yesterday that if you divide a polynomial by a divisor, you get its quotient, all right? So we now know that this is our divisor. Well, that's supposed to be a D. This is our divisor. That's supposed to be a D. This is our divisor. There we go. That's our divisor that we're going to divide into this polynomial, but we're trying to find the missing quotient, x minus r3. So we're going to try to go ahead and factor this by doing long division. So we take the original polynomial from above, which was 2x cubed minus x squared, 2x cubed minus x squared, what was the rest? Plus 18x minus 9. And we're going to divide by the one factor that we know. We know that x squared plus 9 is one of the factors. Okay? X squared plus 9 is one of the factors. So how are we doing on long division? Give me the first right here. What times x squared will make 2x cubed? 2x. Good. So 2x times x squared makes 2x cubed. 2x times 9 makes what? 18x. Now watch how I line it up. I'm going to put the 18x under the other x term. Don't line up 18x with x squared. They're not like terms. So this is the first long division problem where you subtract this quantity, and what happens? Yeah, the negative x squared will come down, and even the minus 9 will come down. So these guys cancel. That cancels, and that cancels. We bring down negative x squared, and we bring down the minus 9. We're now dividing x squared plus 9 into negative x squared minus 9. What would you multiply x squared by to get negative x squared? Negative 1, and watch what happens. Negative 1 times x squared is negative x squared. That's going to be nice. Negative 1 times 9 is negative 9. And what happens when you subtract this quantity? You get a remainder of 0. So we now found x minus r3. We now know the other root of this problem. We now know the other factor, actually, of this problem. I'm going to erase the x minus r3 because now we know that it is 2x minus 1. And now that we have it in factored form, we can find, without a calculator, the other missing root of this problem. One was 3i, one was minus 3i, or negative 3i. The other will be found by setting 2x minus 1 equal to 0. You find the roots by setting the factor equal to 0. If 2x equals 1, x must be 1/2. Last step. Graph the polynomial. You'll see that it should cross at x equals 1/2. Press trace 1/2, and it should produce the other 0. Yeah.
How is that addition of this